We now are going to combine input and output to get a more reasonable, user-oriented, simple program. For that, we need to talk about reading from the keyboard. When you want the user to enter something at the keyboard, they need to be told that they need to enter something. And the jargon for letting them know is to prompt them. And in a text mode like we have here, we want to give instructions on the screen. We've already talked about Console.Write, so we could say, enter your name. Then you'd expect the user to respond. And when the user types at the keyboard, then the response is automatically shown on the terminal or console window that is called echoing. To accomplish this, we have another function from the console class. This time, console dot, instead of WriteLine, it's ReadLine. Now, this is fundamentally different than WriteLine because the data we're trying to deal with is coming from the user typing at the keyboard. There is no parameter, but this will give us back a result, the string of characters typed by the user. All functions to be called need the parentheses, but here we don't need a parameter, so they're just empty, and so the call is just this, console.readline parentheses. In a program, then, where this expression is used, effectively it is replaced by the value, the string of characters returned by the user. That's the same as in the use in normal math, where effectively the value of the expression is what is calculated by the function. One thing to be careful of, with any function that produces a value, the value is lost unless it is immediately used. For instance, if we declare a variable name, we can immediately use the value that's returned here, that is the string of characters typed by the user, by doing an assignment to name, or of course the shorter, just using it in initialization. Now notice that in most operating systems you can edit the line that you're typing in, and you only send it to the operating system when you decide that it's correct, and you indicate that by pressing the return key, or the enter key if you like. This is great to be able to edit, but it means that the return key must always be pressed to signal the end of your input. As a result, a whole line must be read. As a result, it doesn't make sense to have a function console.read not going on to the new line. This function doesn't exist. I just made it up. Well, here we're talking about reading in a name. You may want to have the user supply you with numbers. Let's look at the complication in this program badsum.cs. Now look at it first before going on. There is a problem with this if we want to calculate the sum of two numbers. So we can prompt the user to enter a number, return what the user typed in, assign it to S, prompt again, assign the next thing returned by the user, again using this console.readline, and then the idea, of course, the sum is sum with a plus sign of the two entries, and then we can write out the result going back with our console.WriteLine, and we'll put in a label here, they add up to, and then the sum. This program will actually run, but it is in error if we want it to do what I'm saying in the labels here. It's a common error and fairly subtle. Don't spend forever at it. I'll go on here and show the issue. Think about it. You can stop the video if you want What's the problem? Here's the sample run. Here we enter one integer 23, another integer 9, and it says they add up to 239. What has happened? Here's the 2, 3. Here's the 9. We've crammed the digits together. Why? Console.ReadLine reads a string of characters, a string. S is a string. Similarly with T. Remember, the plus sign is interpreted by C# based on the types of the operands. Here, both S and T are strings, so what does the plus sign do? Crams the characters together, so we produced what really should happen with this function the way it is written now. We have concatenated the two strings. If we want to really do arithmetic, this is clearly not what we want, so we need to add something else new. If we want to add numbers, we must first explicitly convert the strings to the proper kind of numbers. So we introduce another function, int.parse. Parse is where you take text and interpret it in some way in English. And here the int dot means we want to interpret it as an integer, or int. So we can take a string that represents an integer and convert it to the actual int. So here, where we see like 1, 2, 3 in quotes, a string, it would be converted just to the number 1, 2, 3, the int, and so on. So here in goodsum.cs, we have the variation. So this is all the same, except I've changed the names to emphasize the change in type. Here, in what is returned by Console.ReadLine, I've emphasized in the name here that we're getting back a string that will correspond to a number x, but it is not the number x itself. To get an int x, we must get it by using the int.parse function applied to this string that represents the int. And then similarly, I return a y string and convert that to an int y, again using int parse, this time with the y string. And the rest is the same code, only now it makes sense. Sum is now an int, and we're adding two ints, which will give us normal arithmetic, and this should work fine. There can be still other problems here, however. This would not work if the string represents the wrong kind of number. Here's an illustration in C#. Suppose we declare a string s, and here we give it this string of characters that obviously you would think represents a real number. If we then say we want to parse it as an int, parsing this string, we're going to get a format exception. The program is going to bomb out. Here I've just shown the first part of the error message that you get. Input string was not in the correct format. An int can't have a decimal point. That is how we indicate a double literal. And so if we shift and use the parse that converts to a double with the same string s, we get back a reasonable number, 34.5. You must be sure that you use the parse function associated with the correct type. It needs to be double here, not int.